Hello again. Today we are going to cover section 12.2, which discusses chemical calculations. Now, clearly, since this is calculations, you're going to want to make sure that you have a calculator with you, as well as the periodic table, because we will be working with molar masses and molar math. A new tool that we are going to introduce today, which I have posted to Google Classroom, is our double mole map, which looks something like this right here. If you have a printer, I would encourage you to have this printed and beside you. If you don't, you might want to just pull that up off of Google Classroom so that you have it to reference. So let's go back to our notes today. Let's begin with a review problem. The review problem that I'd like to start with today says how many moles are in 5.00 grams of CaC2. So we always begin with the number and unit that we're given in the problem. In this case, it's 5.00 grams of CaC2. Then we set a goal for ourselves. We are asked how many moles of that substance there are. So moles of CaC2 is what we are supposed to convert to. We have done these types of conversions before. We can do this in one simple step. I'm going to put grams of CaC2 on the bottom of my conversion factor because that's the unit I want to lose. And I'm going to put moles of CaC2 on top of the conversion factor because that's the unit that I would like to go to. Anytime you're going from grams to moles or liters to moles or anything like that, remember you can put a 1 with the moles. However, we need to do a little bit of math to figure out how many grams there are in a mole of that substance. So this is where we have to list out what substances we have. We have calcium and carbon in this compound. There's 1 atom of calcium, 2 atoms of carbon. Then we're going to use the periodic table to look up their masses. The mass of calcium is 40.08. So 1 times 40.08 is 40.08. The mass of each carbon is 12.01, so 2 times 12.01 is 24.02. So I have that when you add this up, this should give you a mass of 64.10 grams per mole CaC2. Now that's not the answer for my problem. That is the number that I'm going to put in our conversion factor. There's 64.10 grams in every mole of that substance. Now remember, for mathematics, we will multiply by the top number, divide by the bottom number. In this case, we're going to start with 5 because that's the number that we are given, and we will divide by 64.1. So 5 divided by 64.1 gives me a value of 0.078 moles. Now, today let's take this a step further because in our last lesson, we talked about how if you have a balanced chemical equation that you can convert from moles of one substance to moles of another. In fact, if I go to our double mole map here, it reminds me here in the center that you can go from moles of one thing to moles of another using our balanced equation. So let's read this new question. Our new question says, given the following balanced equation, how many moles of CaOH2 can be formed from 5.00 grams of CaC2? All right, so if we write down what we're given, 5.00 grams of CaC2, and then I write what I'm supposed to change to, which is moles of calcium hydroxide, CaOH2. I will see that this is a bit different from the problem I did up here because in this problem, I was going from grams to moles of the same substance. In this new problem, I'm starting with calcium carbide, CaC2, and I'm supposed to go to a new substance. So if I go to my double mole map here, that's like saying that I'm starting, let's pick a different color here. What do we want? Maybe we'll do purple. I'm starting here with a mass of, in this case, CaC2, but I'm trying to not get to moles of CaC2, which would be right here. I'm trying to go to moles of calcium hydroxide over here. It's kind of like you can take this double mole map and divide it up between what you know, the substance you know, and the unknown or new substance that you're trying to convert to. So if I look at this map, to get from grams of CaC2 to moles of CaOH, I'm gonna have to take 2 steps. I'm gonna have to go from grams to moles of CaC2, and then from moles of CaC2 to moles of calcium hydroxide. So let's go back and set that up in our problem. So I'm gonna draw my 2 conversion factors here. Should probably change back to the blue, it's a little easier to see. In my first conversion factor, I'm going to put grams of CaC2 in the bottom because I want to get rid of that. And the mole map said I have to change that to moles of the same thing. I can't just jump to moles of something different. So now my grams of CaC2 would cancel out and I'd have an answer in moles of CaC2. But I don't want moles of CaC2. So I'm going to put that in the bottom. I want moles of CaOH2. All right, so let's go back and plug in our numbers because that would then cancel out the moles of calcium carbide and leave me the unit I want. So anytime I go from grams to moles, I can put a 1 with the mole side. I have to figure out how many grams there are in a mole of that, but remember, I already did that in my opening problem. There were 64.10 grams in that substance. Now, moles to moles, remember you are not allowed to just put 1 to 1. You must consult the balanced chemical equation. So if I look at the balanced chemical equation, there's no coefficient written in front of the calcium carbide. So I'm going to say that there's 1 because that's an implied 1. I look up the calcium hydroxide. It also does not have a coefficient. So I assume that it's a 1. So mathematically, I'm going to take 5 divided by 64.1 times 1 divided by 1. And when you do that, I have that you should get 0.078 moles of calcium hydroxide. All right, so our link here is the balanced equation, and make sure that you're using your mole map to help you along the way. I think we can take it one step further though. What about if they say how many grams of CaOH2 can be formed from 5 grams of CaC2? Again, I'm going to start with 5.00 grams of CaC2, but this time I want to finish with the units of grams of CaOH2. Let's consult our mole map and see how many steps this is going to take. All right, let me maybe erase our former scribbles on here. Okay. So we had established that the substance that we know in this case is the calcium carbide. That's what we're starting with. The substance that we're trying to find values for is the calcium hydroxide, CaOH2. I'm trying to start with grams of CaC2 and get to grams of calcium hydroxide. So according to the mole map, I'm going to start here in grams of calcium carbide. I'm going to go to moles of, we're still on the side of calcium carbide. Then I'm going to have to use my balanced equation to go to moles of the new substance, which is calcium hydroxide. And then I'm going to take another step to go to grams of that. So this is a 1, 2, 3 step problem. All right, let's go to our problem then. Let's draw in our 3 conversion factors. So in the first conversion factor, I have units of grams of CaC2 that I'm starting in, and I don't want that, so I'm going to put that on the bottom. I'm going to put moles of CaC2 on top. I do not want to be in moles of CaC2, so I'm going to put that on the bottom. And my mole map said after I get to moles of CaC2, I can change that to moles of calcium hydroxide by using the balanced equation. But I don't want moles of calcium hydroxide. So I'm going to put that in the denominator, and I'm going to put grams of calcium hydroxide on top. Now I just need to figure out my numbers. All right, grams to moles conversions. You always put a 1 with the moles. This is still grams of CaC2 to moles of CaC2. I picked that on purpose so that we would have a few less calculations. We've already established that there's 64.10 grams of calcium carbide. Remember, we'd used that in our previous problem. Now going moles to moles, again, we've got to go back to our balanced equation. There's 1 CaC2 and 1 CaOH2. So it's going to be 1 to 1. My last factor is another grams to moles. So I'm going to put a 1 with the moles. We got to do a little math here. There's 1 calcium. And don't forget, the formula is this, Ca parentheses OH2. So I have oxygen and I have hydrogen. And I've got to take the 2 and distribute it across. So there's 2 oxygens and 2 hydrogens. So now I'm going to multiply out. The mass of calcium is 40.08. So 1 times 40.08 is 40.08. Oxygen has a mass of 16. 2 times 16 is 32. Hydrogen is 1.01. So 2 times 1.01 is 2.02. I have that this adds up to be, let me see here, 32 plus 2. Whoops. Sorry, my calculator wasn't turned on. 40.08 plus 32 plus 2.02, 74.10 grams per mole. So I'm going to put 74.10 here. All right, now we are ready to plug this into our calculator. So I'm going to start with my first number, which was 5. I'm going to divide by 64.1. Multiply by 1 divided by 1 doesn't really change your number. Then I'm going to multiply by 74.1, and I get 5.78 grams of calcium hydroxide. And that is our new skill. I would like for us to take a look at your homework assignment here for a second. So you've got the 12-2 practice problems, and I have assigned for you to do a select few of them. For this evening, I would like for you to do number 4, number 8, number 10, number 12. Then on the next page, or in the back side, I would like for you to do 14, 16, 18, and 22. I intentionally chose those because they already have a balanced equation provided for you. I would like for us to do a couple as example problems though. So let's do number 1 together. Determine the mass of lithium hydroxide produced when 0.38 grams of lithium nitride reacts with water according to the following equation. So I'm going to start with 0.38 grams. They say of lithium nitride, so that's the Li3N. And I'm supposed to turn that into a mass of lithium hydroxide. So I need to know grams of LiOH when I'm done with this. All right, so if I go to my double mole map here, let's erase what we've got. Oh, here. Hold on. Okay. Oops, having trouble with my eraser there. Sorry, guys. This time, we have lithium. No, I need to change it back to my pen. Sorry. We have lithium nitride. And then we're trying to find lithium hydroxide. We know grams of lithium nitride. We're trying to go to grams of lithium hydroxide. So that's going to be a 1, 2, 3 step problem. All right, any grams to grams conversion is going to be a 3-step problem. So let's draw in our 3 factors. In the first factor, I'm going to get rid of grams of Li3N because I don't want that. The mole map says I have to change that to moles, and I have to stay with the same compound because I'm on the same side of the equation, or the mole map. Now, I don't want moles of Li3N. I want moles of LiOH, so I'm going to put moles of LiOH on top. Then on my last factor, I don't want moles of LiOH. I would like grams of LiOH. Sorry, it's a little crowded there. I should have zoomed in more. So when I start plugging in my values here, anytime that you have a grams to moles conversion, you put a 1 with the moles. Now I've got to figure out if I took 3 lithiums and added on 1 nitrogen, I have that's about 34.83 grams when I did that calculation. Now, for my moles to moles, I've got to go to my balanced equation. There's no coefficient written with the Li3N, so I'm going to put a 1 because it's an implied 1. And with the LiOH, there's a 3, so I'm going to put a 3 there. Now, in my last factor, it's another grams to moles, so I can put a 1 with the mole side. I need to add up a lithium plus an oxygen plus a hydrogen. When I did that, I got 23.95. Sorry, that's even harder to read there. All right, so I'm going to take 0.38. I'm going to divide by 34.83, multiply by 3, and then multiply by 23.95. And I get an answer of 0.78 grams of lithium hydroxide. I hope that you do as well when you go through that problem. If not, try it again, and then let me know if you have issues. The next problem that I'd like for us to take a look at as an example is problem number 11. Now, a critical step for us in problem number 11 is it's talking about liters of oxygen and being at STP. So I want to remind you that 1 mole of any gas at STP is going to occupy 22.4 liters. Remember, STP stands for standard temperature and pressure. So how many liters of oxygen are necessary for the combustion of 425 grams of sulfur, assuming that the reaction occurs at STP? And the balanced equation is S plus O2 yields SO2. All right, so I'm going to start with 425 grams of sulfur. They want us to change that to liters of oxygen. So I'm going to go to my double mole map. This time, let me clear off my writing. This time, I'm starting with the sulfur, and I'm trying to go to oxygen. I know how many grams of sulfur I have. I'm supposed to get all the way down here to moles of oxygen. Now, for our purposes, I want you to ignore that this dashed arrow even exists. We'll have to explain that tomorrow. So that's not an option for us yet. So we're going to start with grams of sulfur. We got to change it to moles of sulfur. Then we're going to have to go to moles of oxygen, and then from moles of oxygen down to STP. So that's a 1, 2, 3 step process. All right, let's get our 3 factors. 1, 2, 3. All right, in my first factor, I'm going to put grams of sulfur on the bottom because I want to get rid of it. I'm going to put moles of sulfur on the top. I don't want moles of sulfur, so I'm going to put that on the bottom. The mole map says once I get to moles of sulfur, I can change to moles of oxygen using the balanced equation. But I do not want an answer in moles of oxygen, so I'm going to put that on the bottom of my factor. And I'm going to put liters of oxygen on top because that's what I want. So let's go back and fill in our numbers. Grams to moles conversions, I can put a 1 with the moles side. I look up sulfur on the periodic table. It's around 32.07 grams per mole. Now, to go from moles of sulfur to moles of oxygen, I have to consult my balanced equation. And it looks like it's got coefficients of 1 for each of those. Now, moles to liters, we're going to use this helpful hint up here that we had. 1 mole is the same thing as 22.4 liters. So we're going to begin with the 425 that they gave us in the problem. I'm going to divide by 32.07. Then you would multiply by 1, divide by 1, which doesn't change your number. Then we're going to multiply by 22.4 for the last factor, and I get 297 liters of oxygen. I hope that given these sample problems and after reading this section, as well as having your mole map, you are able to complete all of the assigned problems on your homework worksheet. If you have any questions, please make sure that you ask me. Always, I know it takes a long time to write out all of your units and all of your work, but you will really, really be grateful that you did, because if you don't, you're going to start getting lost as to what units you're in and what units you're trying